All right, let's dive into one of the coolest, most mind-bending challenges in AI today. Teaching a car how to see the world in 3D. Just like we do. It's something our brains do without even thinking about it. But for a machine, well, that's a whole other story.
I mean, you look at a scene like this, and instantly, your brain just knows how far away things are, their size, their depth. It's automatic. But an autonomous car has to take a bunch of flat 2D pictures from its cameras and somehow stitch them together into a true 3D model of reality. That is a seriously tough nut to crack.
So, to really get why the new systems are such a big deal, we got to look at what was wrong with the old ones. It turns out earlier AI brains had two major blind spots, critical flaws that really held them back, and frankly, made them a bit unsafe. Okay, so the first huge problem is what researchers call depth ambiguity. You can kind of think of it as the AI being a little depth blind. So what that really means is when a couple of different objects happen to line up perfectly from the camera's point of view, the AI just gets totally confused. It can't tell them apart, and that creates a really dangerous situation where it doesn't know what's actually on the road ahead. Here's a perfect example of what I'm talking about. The old system, using what's called 2D attention, looks out and it might just see one big long shape. It completely lacks the depth perception to figure out that it's actually two separate cars, one behind the other. And that can lead to it making duplicate predictions or, way worse, missing one of the cars entirely. The second big blind spot is a classic case of tunnel vision, and it's a direct result of how a car's brain tries to make sense of all the different camera views at once. This is a massive issue. Your typical autonomous car has, 6, maybe more cameras pointing in all directions, and right where the views of two cameras overlap, objects get sliced in half. These are called truncated instances, and let me tell you, older AIs were notoriously bad at dealing with them. And here you can see that failure in action. Look at the orange boxes. That's where the objects actually are. Now look at the blue boxes. That's the AI's guess. See how bad it is? The old system just looks for the center of an object. So if a car is split right down the middle between two camera views, the AI just gets completely lost. So, how in the world do you fix this? Well, the first big breakthrough is a new tech called DFA3D, and it's designed specifically to cure that AI depth blindness. Instead of just staring at flat pictures, DFA3D basically forces the AI to start thinking in 3 dimensions. First, it grabs all the important features from the 2D images, then, in This Is the Secret Sauce, it estimates a depth for each of those features. Once it has that, it can literally expand its flat map into a real 3D space. And finally, it scans that new 3D world for objects. It's a total game changer. So let's go back to that messy situation from before. In the exact same scenario, the new system nails it. Because it's now sampling information in 3D space, it can clearly tell the difference between the car that's close and the car that's farther away. Just like that, the depth ambiguity is gone. Problem solved. Okay, one problem down, one to go. We've handled the depth issue. But what about that nasty tunnel vision? Well, that brings us to our second big innovation, which is called Graph DTR 3D. And this is all about giving the AIs some much-needed peripheral vision. See, the old way was way too simple. It just focused on one single point, right in the middle of a potential object. If that point was confusing or cut off, the whole detection would fail. The new way is so much smarter. With Graph DTR 3D, it creates what you can call a web of awareness. It's a dynamic 3D graph that checks out multiple points to get the full picture of an object. So how does this web actually work? It's pretty cool. For any potential object it's looking at, the AI doesn't just check one spot. Instead, it builds this little 3D graph. Think of it like a mini constellation of dots floating in space around the object. Then, it projects all those dots back onto the flat 2D camera images to gather clues from a bunch of different viewpoints. This is absolutely essential for understanding those tricky objects in the overlapping zone. And the proof, as they say, is in the pudding, or in this case, the data. Just look at the performance on those really tough overlapping objects. The old model, DETR 3D, it gets a score of about 38%. But Graph DETR 3D, with its fancy new web of awareness, jumps all the way up to over 41%. That is a huge leap in performance, right where they needed it the most. So there you have it. We've got one solution for the depth blindness and another for the tunnel vision. And when you put these two powerful ideas together, you get a fundamentally smarter, more capable AI brain. This table really sums up the breakthrough perfectly. You can see how the older methods each had their strengths and weaknesses.
One could handle depth but not other stuff. Another could handle features but was blind to depth. But look at DFA3D. It's the first one to check all the boxes. It can tell things apart by depth, it can refine its understanding over multiple layers, and it can use features at different scales to see things both close up and far away. It's the whole package.
And the result of all this? When you integrate DFA3D into the existing models, the researchers found a consistent, significant improvement. We're talking about a boost in the mean average percentage of over 1.4%. Now, that might not sound like a huge number, but in the world of AI performance, that is a really big deal. And this quote from the researchers themselves just hammers home why that second fix for tunnel vision was so critical. They literally said that these truncated instances, the objects cut off between cameras, were the main bottleneck holding the entire system back. So fixing that wasn't just a nice to have, it was an absolute necessity.
And that's really why this all matters. We're not just talking about some minor software update here. These advancements represent a fundamental leap forward in how we teach machines to actually perceive and understand the complex, messy, three-dimensional world that you and I navigate every single day. By solving for depth and for peripheral vision, we've given AI a sense of sight that's much more like our own. It really makes you wonder, now that we've taught it to see in 3D, what human sense should we try to teach it next? Maybe to hear, to understand context? The possibilities are really just starting to open up.